Well, hello all. Today I'd like to talk about electric circuits and Doppler and motors and generators. So let's just have a look at some very cute screens that allow us to do those things. Okay, here on our worksheet we've got, for example, in Doppler, we see here, if the light source is moving away from the observer, positive velocity, then the observed frequency is lower than the observed wave, and the observed wavelength is greater, redshift. Star A, redshifts are evident that the universe is expanding. So here's a redshift. It's gone from that, and it's moved to that. So it's moved more towards the red zone. Here, where it's blue shifted, light is moved. If the source is moving towards the observer, the observed frequency is higher and the wavelength is shorter, or blue shifted. Okay, well, that's apparently what it's showing you. That's what blue shifted light looks like. They've taken the light from the star, they passed it through a prism, they've split it into violet, indigo, blue, green, yellow, orange, red, in that order. And the light has moved more towards the red. Oh well, that's the way it is. Okay, let's just stop. That's Doppler. Here's the formula. This is why we love Doppler, because it's only got one formula. Remember, velocity of the source is at the bottom. They can make it more complicated by having velocity equals frequency times wavelength. They may give you a wavelength instead of giving you a frequency. And then you need to know your definition. The Doppler effect is the change in frequency or pitch of sound detected by a listener, because the sound source and the listener have different velocities relative to the medium of sound propagation, or relative to each other is, I think, better. Let's just stop sharing. And let's have a look. So that's Doppler. We're going to be doing Doppler today. And here is another screen showing us Doppler. Let's just share the screen. Okay, have a look at this. Start again. Okay. Look at that. There's an ambulance with its siren. The sound is moving away from it. And notice in front, the waves are compressed or squashed together, so they come to the person at a much greater rate. Now the vehicle leaves the person, so the wavefronts reach the person in longer intervals. So there's a longer wavelength, which means each wave is taking much longer to reach the person. And that is the Doppler effect. Okay, great. And then let's just have a look. We've also got circuits that we're going to do today. So let's just share this screen with you. So here is a very nice site, fet.coloradouniversity.edu. And you can take things like, you can take a battery, you can take another battery. So now we've got two batteries in series, they link together. There's the negative. That's a positive side, that's a positive side. I'm just trying to see if I can see a positive on that. Okay, you take three batteries. Then you can take a wire, join it onto it. Then you can move the wire down like that. You can add a switch to it, and you can add a resistor. You can add a light bulb. You can add another wire. You can say you can build up little circuits like this. How cute is that? Then you can close the, oh, okay, you can move that around. Then you can close the switch, or you can open the switch, close the switch. And those are the flow of electrons. Now we can also probably get the flow as conventional current. Conventional current goes from positive to negative. So that would be, this is the positive side of the battery. You could also look at the same circuit if we were using symbols. So that's quite nice. And then we can grab voltmeter. And you're going to put the voltmeter, say, there, there. Ah, 13.5 volts. Or what if we put it there? 27 volts. Or what if we put it there? It's still 27. So you see the voltage only falls across the resistances, and it falls across 27 in total, 13.5. Okay, so each resistance is 13.5, makes up a total of 27, because the voltage drops according to the resistance. And then I suppose we could even grab, there must be an ammeter here. Okay, so we could grab an ammeter. I guess we could stick it in there. Let's just grab that. Wait, how do we stop this? Switch is closed. And there must be a way of stopping this. Let me think. Light bulb switch. Anyway, you've got to play around with it. Obviously, I haven't played enough, but I was wanting to. I know there is a way of replacing these components, but I'm just going to have to play more. Where is something that says, oh, that cleared it. Okay, so that clears it and starts it again. Then you've got various other components that you can use. Okay. So we could build up electric circuits with that, which is quite nice. Let's just share that again and just see if this has got a way that you, oh, I'm sure if you put it there, oh, you can, sure you can click on it and then you can hit delete. Oh, there we go. Click on it and it produces a dustbin, and then you click on the dustbin and it disappears. Okay, so it's quite a nice site that if you want to build circuits and play with them. So for example, say you wanted to build a circuit with 3 batteries in parallel, which no one seems to ever know what happens if you take 3 batteries in parallel. So then you do that, and you can move this around to there. Do that, move that around to there, and maybe grab a voltmeter. Let's see what the voltage is of each cell. So, how can the voltage be 1 north, 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 north? 10,000 volts. That's impossible. Why would they? Okay, so let's click on that and change the voltage to, why would they have even 100-volt battery? Are they nuts? Let's just see if we can click on that and change it to, I'm sure I've played with this before and it's had lower voltages. How can a battery have 100 volts? I don't have no battery with 100 volts. But anyway, we'll have to work with what we've got at the moment. Take another one. So if that's 100 volts, let's just see what this battery is. It's still 1,000 volts. And that's 10,000, 10,000, 10,000. Ah. So I wonder why our batteries have got such a high voltage. But anyway, let's make this one 100. Let's make that one 800 volts. And that one, let's make that one also 100 volts. And then let's see what happens if you connect these batteries to each other. Whoa. It says the current is flowing. Okay, so why is the current flowing? Let's just delete that there. And let's figure out why a current is flowing. That's 800 volts. That's 100 volts. So obviously the current is flowing from the 800 volt battery is overpowering the 100 volt battery, and it just shorting, it just causing a huge current to flow through there. So it always, so if you've got batteries in series, they must always more or less be the same voltage. If they're not the same voltage, you're going to even find that one battery is going to send a current to another battery. So let's just make all the batteries the same voltage. Let's make that 100 volts each, and then a current shouldn't flow. Okay. So all 100 volts, and now no current flows. So that's what actually happens if you have an appliance that's got, say, 3 or 4 batteries, and you decide to put a new battery in with an old battery. It's just going to discharge the new battery to the same voltage as the old battery. It's going to send a current through it. I learned something. Okay, so I'm going to stop this recording while we're waiting for our class to arrive.